Hello everyone, this is Mo and this is another episode of Designing for 3D Printing. So in today's episode, we're gonna cover a concept called in-trap magnets. So the concept of in-trap magnets simply is you trap your magnet mid 3D printing. So basically you print a few layers, then after that you insert your magnet, which is like this one in mid print, and after that you continue printing upon that magnet. This gives you basically a clean design from the outside, so you do not need to worry about the shape of the magnet in the kind of the cleanness of the overall design and the aesthetics of the overall design. And it gives you a lot of, like, again, the benefit of the magnetic forces of the magnet itself. So with that, we have a concept for today of a salt and pepper shaker. And that concept we're going to sketch first, and after that we're going to take it for CAD modeling as we do. And afterwards, we're going to 3D print it and we're going to connect again and we see how did we do in the overall product design. Let's do that and let's get started. All right, let's start CAD modeling now. So basically what the concept I decided to proceed with was the spherical concept from the sketching. So I'm going to start with that. I'm going to start with a simple revolve, hand sized. So I'm going to again use my own hands for the anthropometrics in order to know what would be the average size human hand. And with that, I will get a ballpark of how big would be the spherical shaped salt and pepper shaker. So I'm gonna use in SolidWorks the single part multi-body option, or this is the way I'm gonna model this part. And let's start. Okay, so now we have a spherical revolved shape, which I think it looks very nice, and it will end up having a good aesthetic feeling overall in the model or in the product itself. So the way I've done it, I checked my hand. It was roughly 78 millimeters, so I rounded this up to 80 millimeters, and I ate from the bottom 8 millimeters. Then after that, I realized, okay, that will be minus like roughly 10% of the overall height. So I just made it more. So I made it like 90 millimeters with a cut at the bottom or at the base to act as the kind of stand for the entire salt and pepper shakers. So with that, I would continue with the modeling piece and of the individual components. So I'm going to do a split line, splitting basically the sphere in half, so signifying the or modeling the salt and the pepper separate objects, and let's do that. Okay, so now I split the body into two pieces, or the two half spheres we needed. And with that, this made me think, and now I'm thinking about where to place the magnet. Where would be the ideal place to place the magnet? Probably a part like this would be better off to be printed on the side. So basically that will be the surface facing the bed. So in this case, I would place the magnet or the entrap magnet in like in on the top of this layer. And in this case, the two pieces or the two shaker pieces will be attracted to each other by the magnet, so they're gonna have like a nice snap to them when they get near each other. So it's gonna be like as if they're like sucked together very quickly. I have my magnets here. Again, these are the 10 millimeter diameter, 3 millimeter thickness diameter. So these are the ones I'm gonna use. They're pretty powerful or they're pretty strong. They have a pretty strong magnetic field. I think they're very decent in this application. They're gonna have a good, snugly kind of tight fit, but they're as well. They will not be too powerful for the forces of a simple application like taking them apart to put salt or pepper on your food. So this is the surface I'm going to model on the magnet. You might have noticed as well I've made some sort of a base here. So this is something I thought about as well. I think it would be beneficial to have here a cap, and in order to refill or fill your salt or your pepper. I think the idea here would be that I needed the cap to be offset a little bit from the ground, so that the cap will not be unleveling the entire base. So that's why I did that, and we're gonna follow the cap design in a second. So, but first let's model the magnetic piece. Okay, so here this is an interesting and an important point that I need to mention. So right now the magnet, as we said, is 3 millimeter by 10 millimeter, and we're gonna apply a revolve roughly in the mid, or actually exactly in the middle of that line span. The question here, or a critical parameter to consider in this CAD model, would be the distance between the magnet and the wall. So right now, at the beginning, I was thinking about having it roughly as like 2 millimeter, and I was like, maybe that would be too thick, because consider here you have 2 millimeters of plastic, and on the other side you have another 2 millimeters of plastic. So that would be 4 millimeters of plastic, kind of as an obstacle towards the magnet itself. So I think let's make this a little bit less. If we're printing with a standard quality, again, this is the direction of printing. This is the direction of printing. So this is the start and this is the end, or this is the direction left to right. You will, if you're gonna follow the 0.2 millimeter height of print, so 2 millimeter will give you, I would say 10 layers. So I would say let's go with less than 10 layers. So maybe a 0.8 millimeters would be like roughly 4 layers. If I would add some buffers as well, because we need to have some buffers along the actual magnet, which is exactly what I will cover in a second, I would make it maybe at 1. And you will see in a second that when we build the plastic around it, it will be a little bit loose in the pocket that we're gonna create right now. But for now, like again, this is where I'm gonna model the magnet 1 millimeter from the wall. Let's continue. Okay, let's talk a little bit here to talk what we have done so far. So basically, what I've done, I was thinking ahead about how to create the surface of or the how to trap the magnet in the model. And the best way to do this, I guess, in this particular model would be to, after we created now the solid of the sphere itself or half the sphere, what would be beneficial is to create a shell feature. So this shell feature will basically create a contour of the same geometry in 3D offset inside or outside if you wish, but in our case we're going to do it inside of the same solid model, hence creating the negative space inside where it will take the salt or the pepper. So I was thinking, okay, now is the best time to create the pocket for the magnet. And basically what I will do is, after this I'm going to do the shelling, so the shell will follow the contour here, and afterwards I'm going to close this one with an additional small extrude. So whilst doing that, basically you saw I did some I modeled a cut. So the cut here, as I mentioned earlier, this is a trap magnet solution. This is not a tolerance fit or interference fit design where we're gonna squeeze in the magnet, because there is a difference. Here with this trap design, I will basically be trapping. I will be printing, as we said, from the bed until the ceiling of the magnet. Then after that, the print will pause, giving me the chance to insert it. Then after that, it will continue printing. In order to do that, I need to make sure that my nozzle is not hitting the surface of the magnet, or even worse, that the magnet is not latching itself to the body of the extruder, right? Due to the magnetic forces and everything. So what I've done here is I created a very clear, like very much of a clearance fit, or a very easy to insert clearance. So I think I used 0.3 at this stage, or even more. Let me remind myself very quickly. And actually it's 0.4. So 0.4 in general is very good, because your nozzle diameter is actually 0.4. So this is basically, you're telling the extruder to move by a nozzle span outwards. And again, on the diameter, this will be 2 nozzle spans, which is very much from experience as well. So this is very much good clearance. The second thing is where this cut will stop. I'm a big fan of making things kind of related to each other. So if I later on wanted to change something in the model, I do not need to enter numbers and everything. So I made it an offset from that surface, i.e. the surface of the magnet, by I think 1 millimeter. Yeah, actually 0.8. So yeah, let's talk about that for a second. So 1 millimeter, like 0.2 millimeters is the layer height usually, right? If you're printing at 0.3, that will give you a 0.2 millimeter will give you 4 layers in a 0.8 millimeters will give you 0.2 in a 0.2 layer height will give you 4 layers. At the 0.3, a 0.8 will give you actually more. So that will give you, actually less. In this case, it will give you 2 or 3 layers, depending on how the slicer will slice things eventually. So in order to be on the safe side, again, I put 0.8. So it will be 4 layers in the case of a 0.2, and it will be 3 layers in the case of a 0.3 millimeter detail level. Again, as you remember, this was left to right or the arrow direction is the printing direction. Sorry, it's not very easy to explain. So if there is this is not very clear yet, let me know, and we could definitely do it. So now we did this, and now we're gonna continue. Okay, so now we did the shelling. So let's again talk a little bit here for a second. I used a 1 millimeter thickness, and I'm gonna use the like I'm gonna basically be printing only the contour. I do not need to print any infill because I want to maximize as well the space of the salt and pepper inside. One of the things I noticed when I was doing this in SolidWorks, sometimes it does that, is it didn't give me except a very limited, like very large thickness if I didn't compromise a surface. So I basically gave up that surface because it's the easiest to remodel, and I'm gonna do that exactly right now. And whilst I'm doing so, I will basically add the cap hole where we're gonna be filling the later on the salt and pepper from. All right, so now I think it's clear what we've done. So we replaced the surface that or the face that we have removed. And with that, I added as well the hole for filling. So I made it a little bit larger, I think to 12.5 millimeter large. 10 millimeters seemed a little bit too small. And again, from a human or user-centric design, I think the larger that hole is, the better, because again, filling might get tricky, and you do not want to have a very small hole diameter here, and it will not help you much. So that was basically it here. So, and again, let's conclude the trapping of that magnet now. Okay, so this is now our magnet is trapped inside. I think that's a good thing. So I think we have achieved what we wanted to achieve. A couple of points here, as you can see, the layer or the edge here, I made it again at 0.6 millimeter. Again, same concept apply. If you are having a 0.2 detail level, that will give you 3 layers. And if you have a 0.3 detail level, that will give you 2 layers. I think that is good enough to establish the base of the print. And as well here afterwards, again, all of this is air, right? So all of this is loose. Your magnet will be pretty much loose in this case. We might be able to tighten it a little bit from this side. And again, when you insert it, it will be basically falling down. So this space will end up being much bigger than this space. Right? And again, I could even hear it now that the magnet will be kind of shaking inside. I think that's a good that's a good thing, or like a kind of that might be a nice thing to hear. But maybe we could make it a little bit smaller in the second iteration. Let's see. I do not want to be presumptuous and assume it was going to work perfectly. But from what it looks like, there is no reason to believe that it's not going to work. I think it's good. Maybe now we add some holes for the salt and pepper to flow from on the top surface. Let's do that. Okay, so here let's spend some time as well talking about why we're modeling this hole to be particularly very large. So you could see here that at the 2.5 millimeter diameter, your nozzle again probably at 0.4, because that's the most common nozzle in the 3D printing industry, and specifically the FDM desktop or home kits like Prusa, like Anycubic, and all of these kind of commercial home desktop 3D printers. You're going to end up having a point 0.4 nozzle, unless you go like this is the stock nozzle, what they call it. If you go with a 1 millimeter, this is a little bit uncommon. If you go less as well, which is point 0.2 and point 0.3, and maybe there is a point 0.1 as well, like I think it's called the mosquito nozzle. So all of these nozzles are there. I'm aware of this, but when I'm designing, again, I'm aware of what is the nozzle diameter. The one I have on my printer is a point 0.4 as well. I'm not planning to change it for this particular print. So I'm saying it's a point 0.4. So imagine, if you will, if you put a 0.25, this is what you're going to end up with. This orange or now blue circle is what you're going to see because of the nozzle diameter, right? Because the nozzle squirts the plastic in this along that circumference. Again, all of this depends on what is the direction of your printing, right? I'm aware of this. So in this direction, probably because this is cross direction of printing, it doesn't matter much. But think about it. When you're printing, at least you give yourself some buffer, and this is maybe the punchline. Give yourself some buffer. So I think 2.5 might be too much because, again, we do not want the salt to be flowing very easily. So maybe a 1.5, yeah, maybe that gives me a little bit the impression it's too small as well. So I was gonna go with the 1.75. And again, let's see. Design is all about iterations, and this is our first iteration there, and maybe we decide to make it bigger in the next print. So let's proceed with that. Okay, so now we finished the modeling of the holes of the salt or pepper shaker. I think I'm gonna keep them both to 3 holes just for kind of being symmetric. I like this idea. What I'm gonna do now is I'm gonna model the cap, right? So the cap will be added to the bottom as you probably see here, and with this I will go ahead and design it. Let's do that. Okay, so now I think we've modeled the cap for the salt or pepper shaker. As you can see, or as you noticed during modeling, there is quite a few parameters I used here. So first of all, I created a shoulder for when you insert the cap, it basically is going to latch a little bit here. As you can see here, everything is basically aligned, which is very uncommon, and you're not going to see me do this a lot. But this is because I need this to be a very tight fit. So this is the reason. And the plastic at this edge will be quite flexible. So I'm relying on this fact that it's going to be a little bit flexible or a little bit elastic to insert the cap. Let's hope I'm right. If not, then I'm going to remodel the cap again. One thing to consider as well is the printing direction for such a part, right? So such a part, I'm again, in my mind, I think it's going to be printing where this is the base to avoid any kind of T conditions and supports and all of these. Again, it's a very small component. So what this means that I might not be able to create a very deep place to place the fingers, right? So usually in these type of caps, you have a space where the fingers go, and then you pull it out. As a substitution, I might need to do a notch from the sides to enable the user to be able to grab it. So otherwise, that would be a bad design. So I'm gonna do that these side notches to enable pulling it out easier. Okay, so another point here, again, we're trying to create the side notches, but again, the shoulder is not big enough, right? And now, if I used a two cutouts of 15 millimeter circle, in this case, I will end up with only half a millimeter on each side for that notch. I think that's not big enough for a human to grip on it. So I'm gonna increase the shoulder a little bit, the one of the cap base, in order to get at least 2 millimeters here. Okay. So with this, I think we reached exactly the point where we wanted, which is 2 millimeter. I think this is cool. And let's proceed. Let's do a quick pre-flight check by sectioning everything basically and checking everything through a print as if it's a normal print. The way to do that, usually what I do is I place it like this, as if this, again, this is the printing, and I go through it as if it's a step-by-step printing. It looks very cool actually too. Of course, I'm not gonna print the cap in this position, but it again gives you an idea that this is how things gonna be printing, and until we go all the way up. Okay. So that direction looks good to me. The second direction, which is the magnet direction, I think this looks fine. I might, yeah, I think I will fillet these edges a little bit. I do not want these sharp corners where the salt or pepper gonna be trapped or accumulating after some time, right? So you want to make it a little bit more curved. I think this looks nice. This looks okay now. I think this will deprive any sticking in the process. This might be another concern here around these edges where again salt or pepper might accumulate after time. So maybe we need to fix that as well. Okay, I think now it's clear. We've solved this dilemma. I think this is better than before. Yeah, by doing so, of course, as always in CAD modeling, you create some ripple effect in some area. So I had just to readjust or reorient the cap. I think that's cool as it is right now. Again, this is iteration one. Maybe we need to do another iteration or so. But let's do that, and I think now we're about to mirror the we're gonna mirror the objects. Okay, so this is now our object. I think it looks very cool. I like the contour. I like the spherical shape. I think it's very nice. Actually, this is I have a disclaimer. This is actually a invention in the 3D printed form of an existing product I had before. But I like the spherical shape. I like it. I think it looks cool aesthetically. It's very pleasing to look at. And I think now we're about to take it to 3D printing. And let's maybe start slicing. As you can see here, I did some cool kind of trick on the bottom here, where I made the black cap on the white shaker, and the white cap on the black shaker. And the idea here is basically to make it a little bit more visible, and kind of acts as a signifier or as an indicator that this is where the cap is, and with this where you could pull it out and so on. So what I'm gonna do now, I'm gonna hide the unnecessary objects. The cool thing about this print as well, it's identical, it's symmetrical, so you're gonna just need to change the filament but use the same G code that you export once, but you're gonna do it twice, once in black and once in white, and then after that you swap the caps. So let's do that right now. Okay, so now I exported it to the Prusa slicer. As you can see, this is how it's going to be printed as said on the 3D printing bed. What we're going to do right now is we're going to slice it at, again, I would go with the first iteration, I would go with a draft of a 0.3 millimeter, and afterwards I'm going to do maybe the more detailed after a detailed print after we verify that everything works perfectly with the first print. So I'm going to do a 0.3 and sorry, thank you for the suggestion, but I do not need that help right now. So what I'm going to see right now here is okay, well, how did it slice at with these parameters? I think looks pretty nice. And then, yeah, something here is not fully right. This should be, again, a space, but it's for some reason considering it a solid object. Let's see. Okay, so finally we did it. So I think there was something messed up in the settings. So I just adjusted that, but I think now it looks cool. So now I'm gonna re-import it again to give you the again the commentary. So basically, what I went here, I went and I put it to the bed and I exported the objects, or I split the objects, and with this you could select every object on its own, and basically for some reason it's still exporting the magnet, so I'm gonna just delete it, and this is okay. And now this one, I think this as well is okay, and we do, again, we're gonna do the 0.3 draft as I said, so let's use it as such. We're going to do a 0% infill. 0% infill means I do not need to have any infills, which is, I think in some printers it's called vase mode, but yeah, for the sake of this one, I think it's cool. So this is how it's going to print. So you're going to print, and you need to select here, I think, after, just before the fillet. See, just before it actually starts to close that fillet, and close on the magnet. So see this layer, the difference between layer 14 and the layer 15, I'm gonna insert here a pause. Okay, so this pause means that I will be pausing the printer at this stage to insert the magnet, and with that pause I will be basically enabling the magnet insertion. So just be careful. I think this could be more important in the second print than the first print, how to direct your magnet. So again, to make sure that the right polarity of the magnet is placed, north and south. So just make sure it's north versus south, or north facing south, or the other way around, but do not, of course, put north and north, south and south, just to make sure that you do not get like kind of a repelling effect, not like that is not desired, and it will be too late after you print. You will not be able to take it out because again it's an in-trap magnet. I think with this, let's go ahead and test it and print it and come back together and see what have we created. See you later.